Welcome back to the channel. In the previous video, we were able to set up our API gateway. We're also able to implement the JWT authentication with dedicated authorization server, and we're also able to build our Eureka server for service discovery. Now, as part of the microservice series, we'll be diving into our income and expense tracking service, which will help us manage financial data in a secure and scalable way. In this video, we'll take a look at how the income and expense service fit into our overall architecture, connecting through the API gateway and integrating seamlessly with our services like the notification service and the authorization server. I'll show you step by step on how to design this service using the best practices. And we'll also make sure it supports large data numbers and ensuring smooth communication across our microservices. I would also try as much as possible to make it as simple and understandable. If you are new here, make sure to hit the subscribe button to stay updated with all the parts in this series. And if you missed any previous video, go check them out for a full understanding of this setup. Let's get started. The first thing we want to do is to create our project. And of course, the language is Java and the build tool is Maven. And we'll be using Spring Boot version 3.3.5. And then our group name would be on it. Then our artifact name will be income expense. That's fine. Then we can add a description. Awesome. Our packaging will be jar and our Java version will be Java 21. So let's just generate this. Before that, let's add our dependencies. So we need JPA, a dependency, we need Spring Web, we need Postgres, we need, let's use Lombok. We also need Eureka, the client, since we are using Eureka as our discovery. We also need the Spring Security. Okay, for now, let's just generate this. Awesome, it's generated, then we can extract it. Awesome. So now we can import this into our IntelliJ. So let's do that quickly. Click on the open and then want to go into the downloads. Awesome. Open new windows. Awesome. So the first thing I want to do here is first be sure that I have all the dependencies. Yep, we have all the dependencies we need. Good. And then of course, the next thing is, of course, from the previous video, I've been saying I like using a YML file. So I'll just change this and rename this file. I'll name the property files to a YML file. Easy. And then I can restructure this. Good. And then I want to change the port since we have a lot of ports running at the moment on our Docker. If we go back to our Docker, we see the ports they are running on 4000, 5432, 8761, and 8080. So I'll just change this to 8081. Awesome. So the first thing I want to do here is set up my database and also set up my Eureka server, or make sure that this particular application registers on Eureka server. And how do I do that? Just to make that a little bit faster, I'll go into the authorization service. We already have all those set up in there, and just do a copy. Let's just do that. So this is for our authorization server. Of course, in production, you would not want to do all this. This is just for test. And also we need our Keystore, our cert for decoding and encoding the JWT, right? So let's just copy everything we have here and we'll make changes over there, right? Pretty easy. And then let's dump it here. And then let's just look at what we do not need here. The first thing here is we already have this. So let's take it out. And then we want to copy this. The name is already there. We're just trying to make this as fast as it could be. All right, so let's put the port here. Okay, we already have the server. And then we want to do the port. And then of course, our context path could be API, doesn't really matter. All right, that's fine. Here I want to change the name to income expense, just to make it faster a little bit. All right, so all of that things look good. From the previous time we used password and Postgres, it's just something simple. And then of course the application name is income expenses, no problems. And then our port is port 81, our context path is API. And then we have our Keystore. Now let's go copy our Keystore too. We need that. Just copy it and then put it here. Just paste it. Awesome. So I think we're good to go. We can now start our coding, but let's just take a look at it line by line and see we're not making mistakes. Awesome, we're good. The next thing I want to do is I want to make sure I load this Keystore and I'm able to decode and encode token as it should be. So let's do that. So to load our Keystore, let's just create, let me expand this. Let's create a configuration package. Just name it config. And then we can just create a class. We need to create a class here and call it Keystore config. That's fine. And then just like the previous videos, we need to annotate it as at configuration. All right, awesome. So the first thing we want to do is let's just declare a variable. We need the password to the Keystore, right? So we just name it Keystore password. That's fine. And then we want to pick the password we have from here, right? That is keystore.password. All right, let's do that. And to do that, we use the add value, and then we use the $, and then it should be, to be sure, let's just copy that keystore.password, right? So awesome, that settles that. All right, so the next thing we want to do is we want to create a bean. Let's create a bean. A public. And it's bean that returns the Java security Keystore. Awesome. So what do we want to do here? The first thing we want to do is we want to try to load the Keystore file from the path. All right. So let's get the path first, right? And the path from here, the path is keystore.path, right? So we can just go back there and just maybe just copy this. Let's just copy this to make it faster. Okay, so path, and this will be Keystore path. Awesome. So the first thing, again, as I said earlier, is we want to pretty much, we're missing something here. Good. That was good now. All right, so now we want to load it. Let's do a Keystore. Keystore equals Keystore dot get instance, and then the instance we want to get is JKS. If you remember from the previous videos, we actually created this particular instance, right? And then we want to do a try, and then let's just try by resources or with resources. And to do that, we do an input stream, then call it Keystore stream. Let's just call it Keystore stream. Now let's get class. Let's get class loader. and then we want to get the resource as string. Good. And then we want to get the file itself, and that's the Keystore file, right? Keystore path. Awesome. Good. And then the next thing we want to do is, if it is not null, we want to check if it is not null or if it is null. For example, if it is null, let's just throw an exception, right? So let's do that. If it is null, then what do you want to do? You want to throw a runtime entry. Let's just throw an exception. New runtime exception. And then we can just put in a message in there, maybe Keystore file not found or something, which is good. Awesome. But what if it's there, right? What do we want to do? If it is there, we want to load it, right? So we'll just do the keystore.load, and then we pass in the stream and then the password. Awesome. So let's just throw this exception, the catch, add exception to method. Good. Awesome. Yeah, this works. We can just put a try catch between them. That's fine. All right, this works. And then the next thing is we want to return something, right? So we want to return the Keystore. Awesome. That completes the Keystore config. So the next thing here, let's just create our object, right? So to create our object, let's just create another package, and we can just call it models. Doesn't really matter. Then let's just create our object. Now, since we are dealing with income and expenses, right? There are certain objects you need, which are, of course, you need the ID. We also need the username of the person that is creating or trying to fetch the data. We also need the amounts, of course, because we're dealing with numbers here. We need to make sure that the application handles huge numbers. For example, when you have millions and millions and millions, we want to make sure that happens. Also, we want to make sure that we have the different type of transactions, which is the income or the expenses. And also, we also need the date, right? So let's just, first thing we want to do is create the object, and we want to call the object, let's just call it transactions. All right. And then we want to use the add data. We want to use the Lombok add data. All right. We also want to, because we are saving it into the database, we want to use the entity annotation. Entity. Awesome. So, all right. So the first thing we want to do is create the ID. We'll make it a long. That's fine. And since it's our ID, we annotate with that ID. Awesome. And then we want to make sure that it auto-generates. And how do you do that? We do a generate, generated value. You want to use a strategy. Generation type to be identity. Awesome. So that settles it. So what do we need? What other things do we need? As I said earlier, we need the ID of the user either creating or fetching the data. So we need a field for the ID. So we can just do a private long user ID. And how do we get that? Let's see what data type our ID is from here. Okay, it's long also, so we can do long, no problems. All right. Let's just give it a colon. Cannot be null, so yep. Awesome. So the next thing we need is the amount. We're talking about the amount, so we can use a big decimal here. Awesome. So we do amount. And then it cannot be null. And then we can also set the precision, right? Let's just set the precision to 20. And let's also set the scale to 2. Awesome. Good. Now, another thing we need is what type of transaction we're talking about, right? We can have the income transaction or the expense transaction. Now, for this one, I'm just going to create an enum. Let's just go into package and create an enum. Enums package. All right. So here, I'll just create an Java class, an enum, and then we'll name it transaction type. Let's just name it transaction type. Good. In this enum, right, what we want to do is, since I said we need income and expenses, so what we need to do is just come here and create, just type in income, and then we type in expense, right? Good. Now, we want to be sure that this particular income and expense is not case sensitive. And so when someone from the front end just types in maybe income in lower cases or maybe upper cases, we want to get the same result irrespective of the sensitivity of the case. So to do that, I would create a method to perform the case sensitive lookup for these particular transaction types. And how to do that is I just use a public, let's make it static transaction type, right? And then let's just name it from string, for example, right? And then we'll do string, and then we'll pass in the value, right? Good. So what we want to do here now is save. We'll do a loop for the transaction type, and we get the values. And then we want to say if the name equals ignore case. If you remember from previous videos, we talked about this equals ignore case. So we want to say if it equals ignore case the value, we just want to return the type. Otherwise, what you want to do is throw an error. Let's just throw a legal argument, for example. Let's just throw an illegal argument. Unknown enum type. Yeah, this should work. Awesome. Now we can go back to creating our object, all right? And then we pass in the enum, right? So to do that, we just do transaction type. There you go. And we name it type, right? You can name it whatever you want. I just name it type, which is good. And then we want to, because it's an enum, we would use the annotation at enumerated. And of course, enum type is string. And then can this be null? It cannot be null, so let's just use that column. Nullable equals false. Awesome. What else can we add here? We need descriptions, right? So let's just add descriptions too. Private descriptions. Good. Description could be null, doesn't really matter. Okay, we need one more thing here too, which is the transaction date. We definitely need the date, and so we can just do a local date time will be fine. Transaction date. Awesome. Can also not be null. Okay. Good. This is awesome. For this transaction date, right? We do not want to send transaction date anytime we're sending the data, right? We want transaction date to auto-generate anytime the data comes in, right? So for this, to do that, we can actually use the at persist or at pre-persist. So which means before it persists, it generates this particular date and then persists the data. And to do that, we can always do at pre-persist, and then we create the method to do that, right? Let's just make it void. Call it on create. Okay, good. So what we want to do is, if the transaction date is null, right? We want to do transaction date equals null. Then what do we want to do? We want to just do a transaction date equals local date time dot now. Awesome. That solves it. So every time we send our data without the date, it automatically creates this and then persists it. Now, this is good for our object. We already have the data which handles the getters and setters and all of the stuff. Awesome. Let us also do something. Since I do not like using my object for request, for making requests and responses, so I'll just create a DTO. Let's just create a DTO. And we'll make a class that will use, or an object that would use for making the request and the response. All right, so we can just do transactions DTO. That's fine. All right, for here, all we need here is at data, which is good. And then what we need, the fields we need, of course, we need the username, the user ID, right? We need the amount, what else? We need the transaction type, transaction type, and then we need the type. Good. What else? We need the description, assuming we have the description. We need a transaction date. All right, good. So now let's jump into the implementation of the code itself, or the logic itself. The first thing I want to create is the repository. Again, from the previous classes, we talked about the repository, right? It's the interface we use in communicating with the database. So we just create an interface. Let's just call it transaction repository. Awesome. Then of course, I like to use my annotations at repository. We'll be using JPA, so let's just extend JPA. JPA repository, and then we'll pass in our object, which is the transactions, and then we want to pass in our ID, which is the long. Good. Alrighty. Let us also create our service where our logic would be. And then we name it transaction service. And then we want to use the annotation at service. That's fine. All right, in our service, let us start implementing our logic. The first thing I want to do is bring in my repository, transaction repository. We'll just name it repository. Let me use the constructor. Okay, and then we bring it in. All right, good. Let us first implement the logic to add the transaction. And what do we want to do? What we want is simply just to add the transactions, right? We'll create a method to do that. And then since we have a DTO that we want to return and we want to use for our request, we just use the DTO here, and then we name it add transactions. All right, and then it also take the transaction DTO. Let's just make it transaction DTO. Good. All right. So what we want to do is, first of all, we want to get the ID of whoever is adding this, so it is specific to a particular user. Say, for example, a user A and a user B are adding transactions. we do not want user A to see what user B is adding. All right. So to do that, we need to get it from the token that we are passing in. And before we can get it from the token, we need to set some filters and security context, right? Let's just do that first. So let me just create another package and call it security. And in here, I can always create another class. Let's just call the class JWT token filter. Let's just call it that name. All right. And for this one, we want to extend the once per request filter. Per request filter, awesome. So this one, and then let's just implement the methods. We want to use the do filter internal. That's fine. Since we'll be working with the token here, so let's just bring in the token store we created earlier, right? The bean. So to do that, we just want to inject it. Let's use the constructor. Keystore. Remember, we already created the bean earlier, so which is good. And then we want to add the constructor parameters. Awesome. So now let's start our implementation, right? The first thing we want to do is, if you remember, from our previous videos, right, we're using this token, we're getting and creating our token, and then we're using this token. And before you can make requests to the income and expense, you need this token in the auth header here. So you need to come here and then of course click on the bearer token, right? So it's going to ask you for the header. So if you come here, it's now going to show you something like authorization. So we want to get the authorization header, right, which holds the token. And to do that, you can just do a string. We'll pass it into a string, and then we want to get the auth header equals, then from the request, which is this request dot get header, and then what we want to get is the authorization, right? Awesome. Then after that, what we want to do is we want to check if it is null. If it is not null, we want to get the bear, right? So we just do if auth header is not equal to null, and auth header starts with, right, bear space. So what we want to do is we want to take out the bear. We just want to strip it out, and then we'll do the string, just get the token, does substring, then we want 7. All right, so how did we get 7 again? Let me fix this. All right, 7. The bearer has 6 letters in it, and then you have this space, which makes it 7, right? So that's what we want to do. We want just to take all this out and just get the token itself, which is good. And now the next thing we want to do is we then want to use our public key to decode the token, right? To do that, we can just do a public key. Public key equals, then we use our Keystore, then we get the certificate. If you remember again from the previous video, we already set our alias, so we need our alias here. Our alias was auth server, if you remember, and then we want to get the public key. Awesome. All right, let's add our clause here. Awesome. So the next thing we want to do is we want to get the claims, right? We want to get everything in that particular token. And how to do that is we just use the claims. Yep. Claims equals, then we use the JWT parser dot, want to set, and then want to pass in the public key. We also want to pass claim here, and then want to pass in the token, which will, and then want to get the body. Simple. All right, and then from there we also want to do something. We want to get the rows. If you remember from the previous one, we already set in the rows. We need the rows, and then we need the user ID, right? You would understand why we need the role and the user ID soon. But let's just first get the role, right? So to get the role, we do a list of string because we already set them in. And then let's just do roles. Let's name it roles equals. Then from the claims dot get, and then we get the role. Awesome. And then we extract as a list class. Dot class. Good. Awesome. And then we want to convert the roles to granted authority object. So let's just do that. To do that, we do a list of granted authorities equals roles dot, let's just stream dot, let's do a map to simple granted authority. And then we want to collect to we can just collect to a list, doesn't really matter. Can collect to a list, but let's collect to a list. To a list, which is okay. Awesome. And then we also want to get the user ID, right? So we do a user ID equals claims dot get user ID, and want to pass it to a long class dot class. All right, for those that don't understand this, right, let me just give you a little bit of context to this. We already created the authorization server, right? And the authorization server is generating this token. Now, if we take this token, let me just take this token and go to, say, JWT.io, for example, right? And then we'll pass the token here. If you take a look at this, it's coming with different things. The payload is coming with different things. And one of them is the role, the user ID. And this is what we're trying to get. We're trying to get the user ID and the role from this particular token, and then we use it, okay? So now we have the user ID, we have the role, right? So the next thing we want to do is just create an authentication object with the user ID and the authorities, right? How to do that? We just do a username, password, authentication token. Yeah, this is what I need. And then we want to call it authentication, doesn't really matter, equals new this. Okay, good. All right, so what do you want to pass into it? You want to pass in the user ID. Credential is null, definitely. Let's see. And then we want to pass in the authorities. Awesome. Then we want to set the details. Authentication token dot set details, new web authentication details source. Good. Then let's build the details with the request. Awesome. And the next thing we want to do is we want to set the security context. What the security context does is to make the user authenticated. All right. So we just want to set the user as authenticated after everything has been done. So how do you do that? You just do a security context holder. Yeah, dot get context dot set authentication as the authentication token. Awesome. And of course, if there's an error here, we have different exceptions here. One of them is the Keystore exceptions, but let's just make it a bigger exception, right? Let's just make it a bigger exception just to cover all the exceptions. And then we can always just pass in a message here. For example, say response, if everything doesn't go well, want to do a response.send error. Let's just send an error. And then we want to do an HTTP servlet response. Yep. We want to set it as unauthorized. Unauthorized. Good. And then pass in the message with the invalid token. Good. And then, of course, after trying, it should break. All right. So the next thing is, if everything seems good and everything looks good, we then want to return the filter chain itself. So we just do a filter chain dot. We want to do the filters. Then we want to pass in the request and the response. That's it. That's it for the filter. But you can decide to add more things depending on your own use case, right? So again, we're just making it as simple as it could be. Okay. All right. So let's go back to our service class to continue with our implementation. So the first thing we want to do again is we want to be sure that the person that is sending this has a user ID, right? So to do that, we want to get the user ID. So let me just create a new method here to get the user ID. If you remember, we already set the user ID here in the token. From the token, we already passed it into the principal here. So let's just go back there and then get it. And so let's return a long because it's a long, definitely, right? And then let's just say, let's name it get auth user ID. Let's name it that. All right. And then what we want to do is we want to do a long user ID. Let's just get it equals, then we use the security context. Dot get context dot get authentication dot, let's just get the principal. Good. And this should be long. Let's cast it to long. That works. Awesome. And then the next thing we want to do is we want to return the user ID. That's it. Then we get the user ID. So the first thing we want to do before adding it is, again, let's get the user ID. Get also user ID. Good. And then from our DTO, then let's set the user ID. Awesome. That's the user ID. Good. The next thing is we then want to map our transaction DTO to our transaction entity. To do that, I already have a map struct, right? We have a map struct. So let's create a configuration for the map struct. The map struct is just to help us with easy mapping of the two objects. So let's just go into the config and create that. That shouldn't take us too much time. So we create an interface. Then we name it transaction mapper. Which is fine. Good. So what we need is we need a mapper annotation. And then we need to create the mappers. So we do a transaction. We create the instance. Mappers. Dot. Just get mapper class, which is the transaction mapper class. Awesome. Good. The next thing we want to do is map our transaction DTO to DTO. All right. Transactions. Nope. Transactions, which is our model. Good. Awesome. Next one we want to do is map to our transactions. All right. Entity. Then we want to pass in our DTO. Good. That solves it. So let's go back to our service and then let's do our mapping. So to map it, we just do a transaction equals. Let's inject the mapper class. And to do that, just do private final transaction mapper. Good. Equals transaction mapper.get instance. Awesome. So let's use that. Since we're trying to map to the entity, we just use the to entity and then we pass in the DTO. Awesome. So the next thing we want to do is save our data. Alright, do we have our repository? Yeah, we have our repository. So repository.save. And then we pass in our transactions. And let's just return it again. Let's return it. And if you remember, this time it should come back with the transaction date, right? So we just do a transaction mapper dot to DTO. We map it back to DTO. So save this. Awesome. So this should work for adding our transactions. But first, to test this, let's just test this. Before we can test this, of course, we need our controller class. Let's create our controllers. Good. Then, of course, we want to annotate it with REST controller. That's fine. Let's also add a request mapping. And we can just add / transaction. Good. All right. Now let us inject our service. All right. Awesome. Since we are sending a request, so which means our HTTP request should be a post mapping, right? So let's just create the method to add the transactions, right? Now let's return the response entity. Our transaction DTO. Good. Let's just call it add transaction, and then our request body will definitely be the transaction DTO. Awesome. So what we want to do is we want to, since we are returning the transaction DTO, so saved transaction equals transaction service dot add transactions, and then we want to pass in our transaction DTO, and then we want to return a response entity of an OK, and then the saved transaction. Good. This would work for the add transaction. So if you notice here, I'm just putting a post mapping here. I can decide to add another thing here, maybe just another URL, but it doesn't really matter since I already have this request mapping, which means this request mapping should work for this, all right? Before we test this, just so you know, this would not work because we already have Spring security in our dependencies, right? So we will not be able to use this. It will keep giving us a for unauthorized or forbidden, right? So what we need to do is we need to create our security configuration to allow the endpoints that we create and also some other stuff, right? So let's just quickly create that. All right, to do that, let's just go into the security, right? Just create a new class. Let's name it security config issues. And then we want to inject our JWT token. First off, let's just do that. JWT token filter. Let me use the constructor. Good. Then I want to create a bean. We've done this before, but there's a slight difference in the way we implemented the previous one and this one. So what we want to do is we want to create a bean of the security filter chain. The filter chain, then we call it security filter chain, no issues. And then we want to pass in an HTTP security argument. Now, what do we want to do here? The first thing we want to do, we've talked about this again, the previous class, right? We want to disable the CSRF, which is the cross-site. We want to disable the cross-site, which is the CSRF protection. So how to do that is we just do the CSRF, do CSRF.disabled. That's fine. Let's also make the session management. Let's make it stateless, all right? So we can do a session management, and then we do a session dot session create policy. Okay, awesome. They want to make the policy stateless. All right, the next thing is we then want to make sure that our endpoints require authentication, which means a token must be passed to allow this, right? So how do you do that? We then want to use the authorized HTTP request, and then we pass in the auth, and then that'll be auth dot request matchers, and then from our controller I can just copy this, and then also allow everything after it, and then want to make sure they are authenticated. Good, awesome. So after that, what we want to do is we want to add our filter. So we want to do add filter before, and then we pass in our JWT token filter, and then we use the username password authentication filter class, and then we want to return our http.build. Awesome. So what do we have here? Let's add exceptions, and then that's all with the security configuration. Oh, we are missing some other annotations though. So let's use the at configuration. Definitely we also need the at enable, what is that again? At enable web security. Yep, and then we need one more at enable let's use method as our security. Awesome. So that is all for the security config. So now let's test this. Okay, let's just go to our main class and let's run this. Awesome, this is running. Okay, so the first thing we want to do is definitely we want to generate our token. We have our token, and then we want to build our request, right? So let's just create our request. We know that it's running on port 8080, so we do 8081, sorry. So we do HTTP localhost then 8081. And then what do we want to do? We want to add our transactions, right? So let's just go here. We want to do /transactions, and then let's just paste this here. Now we want to create our body, right? So what are the requirements here? If you go back to the code, the DTO is what it's accepting. It's accepting the DTO, right? Yes, the request body is the DTO. So what do we need to pass in here? it's looking for definitely the user ID, but we're not passing that manually. We're getting that from the security context, but we need the amount, we need the transaction type, we need the description, and then of course we do not need the date because we're not passing the date manually, right? We're auto-generating the date. So let's just pass in the amount, the type, and the descriptions, right? So let's just create that. And to create that, we just create a JSON, and then we want to do amount. Say for example, let's just say amount is 1000. Let's just do 1000. And then we also want to pass in the type. Let's say income. We also want to pass in the description. We can just call it freelance work. Doesn't really matter. All right. So this 3 should be enough. So let's try to post this. It has to be a post, definitely, right? So let's do this. It's saying 404 not found. Yes, that's because we have our context which you're not providing. So let's just provide our context. All right. I'm expecting this to come back with a forbidden good. We have an error here, which simply means that we are not authorized to do this, right? Again, we have to go back to our authorization server, generate the token, okay? And then when we generate the token, we go back to the API, just go to authorization and click on the bearer token. And then let's just paste the bearer token here, and then awesome. That really worked. And it came back with the transaction date, and of course the user ID and every other details. Awesome. Now that we're able to create a transaction, let's just take it a bit further by getting, say, summary, right? If we have multiple transactions, we need summary, right? So let's just create another endpoint for summary. And to do that, we can just do, that's going to be a get. And let's just name it summary. Okay. And then for this one, of course, definitely it's going to be public. And we want to return a response entity of, let's make it a map. Good. And a map of string and big decimal. Good. And then we call this get transaction summary. Let's stop this for a bit. Good. All right. And then we can just pass in a request parameter. Now here we want to say, okay, if, for example, we want the summary for maybe income or expenses, or we just want a summary for everything, we can do that, right? So let's just use a request parameter to do that. Request param, and then we just make it not required. If you pass it in, fine. If you don't, then it's okay. So we just want to make this a string of type. Good. So now what do we want to do with the summary? What we want to do is, assuming that the transaction type is not null, we just want to get the transaction type. So let's just do a transaction type, transaction type equals type, it's not equal to null. Then what you want to do, you want to do a transaction type dot from the string itself type, and then null. Good. Then here we want to do a map of string and then big decimal. Good. Then want to make a summary. Now let us go and create, let's go into our transaction service and just create a method for our summary. And what do we want our summary to do? So let's make this public. Of course, it's returning a map, string, and a big decimal. And then we just want to name it again, get transaction summary. Good. And then again, transaction type. Okay, let's import this. All right, let's just declare a map that would use equals, let's name it summary. New hash map. Good. If the type is not null, right? We want to check if the type is not null. Then what do we want to do? We want to do a summary by a user and the type. So in this case, as I explained earlier, you have user A and B, but you don't want user A to see what user B is doing. So we want to make sure that it's getting that data specific to a user ID. And to make that faster and to make that easy, we'll just go into our repository class. Let's just go into our repository class to do that. We can make it so easy for us. So we can just return a big decimal. Let's just create some amount by user ID. Let's just do that. And the type. Okay. And then we want to pass in our parameter. And then our parameter will be, of course, the user ID. And of course, it's a long. User ID. And then also we also want to pass in our transaction type, right? So that's param. Then that should be type. Okay. And then transaction type. Good. Now to make it easy, we'll just use a query, right? We use the @query just to make it easier to query our database, right? You just do a select, and I like to use the coalesce. So for this case, I'll just use the coalesce. So we can just do a select coalesce. Then we'll do a sum. Let's say t.amount, comma, and that'll be from the transactions class. Transactions or transaction, let's be sure. I have a database transactions. Okay, t, because we use t here. T. Okay, good. Where t.user ID, are we sure about that? User ID, good, equals user ID and t.type equals type. So let's take a look at this again and see if this is right. Select coalesce and the sum t.amount from transactions t where t.user ID equals user ID and t.type equals this. Okay, this looks good. And then we can go back to our service and use this. So if it is not null, what we want to do is return a big decimal total, which is equals to repository dot some amount, and then we'll pass in our get username. That's fine. And then we can also pass in the type, right? Fair enough. And then in our summary, the map we created here, we just want to put the summary dot put. Now I want to dynamically check if the transaction type is either income or expenses, right? So what we need to do is just do type equals transaction type dot income. If it is income, what we want to do is just do a total income. Otherwise, I just want to do total expense. And then we want to pass in our total. Fair enough. Straightforward, right? But otherwise, if it is null, right, what do we want to do? Let's just implement that too. If it is null, what we want to do is we just want to get total expenses and total income, right? So let's just do total income and total expenses, right? All right, so here the type will be income, and here the type will be expenses. Good. And then what do we want to do? We want to negate them, right? Just do a big decimal and sum total equals total income dot subtract total expenses. Then we don't want to put the summary in. I want to put in total income. We want to put in total expense. And then we want to put in sum total. Good. And then we want to return the summary. All right, let's go back to our controller and then complete this. So this would be transaction service dot get transaction summary, and then we'll pass in our transaction type, and then we return response entity dot OK with the summary. All right, so this is slash summary. So this then would be transactions slash summary. All right, let's test this. Since we need the transactions slash summary. Okay, awesome. And it should be a get, not a post. Hopefully our token is still valid. All right, there you go. So we have, if we go into our database, we have freelance work and freelance work, income and income. And let's just add an expense to it. No. So this is total income is 2,000, total sum total is 1,000, total expenses is 1,000. So let's just refresh this. I think it's not loaded. So let's refresh this. Okay, awesome. So we have 3 transactions. 2 of them is income and the last one is expenses, right? Which is good, which means we are getting our data the correct way we're supposed to get it. Now, what if we then want to test with the transaction type, right? So from the code in the controller earlier, we passed in the transaction type. So to do that, we just need to pass in the parameters, and the parameter is pretty much the type. Let's just say we want to get the income equals income, right? And let's test that. Good, awesome. So we have the total income. What about if it's expense? Good, and then we come back with expense. And if we do not pass in any parameter, we should still be good coming back with all the summary. Let's assume I want to get, let's do get mapping. Let's assume I want to get all the transactions, irrespective of the user ID, whoever created it. Now, that particular privilege is meant for only the admins, right? So I'll teach you how to like secure that endpoint so that only admins can actually use it. All right. So let's just do that. Let's say, let's just name it all transactions. Right. So now we just do a public. Let's return response entity, and then we just want to return a list. Let's return a list of transactions. Let's do that. Transactions DTO, that's fine. And then we want to name it get all transactions. That's good. Alright, so what do we want to do here? We just want to return all the transactions, and so to do that, let's just do a list transactions DTO all transactions equals transaction service dot. We do not have a method for it, so let's just create that. Transaction get all transactions. All right, let's create that. Good. So what this wants to do is simple. It's just going to return transactions, all transactions equals transactions repository dot find all. Awesome. And then we want to return all transactions dot string, because we need to return the transaction DTO, a list of the transaction DTO dot, and we want to do a map, and then we want to do transaction mapper, and then to DTO, then we want to get it to list. Awesome, that solves it. So let's go back there and just see this. Okay, good, this looks good. And the next thing is to return the response entity dot okay and all transactions. Awesome. So let's try this, and what we want to do is transactions slash all transactions. All right, and hopefully our token is still valid. And it's still running. Speeding up. Let's try again. Okay, yep, we can try now. Good. So we get back all the transactions. That's because we have not restricted it, right? Now let's just try to restrict it and see what happens, right? So if we look at our JWT token, right, from the last time, we had the JWT token having the role of a user. To secure this to a particular role, right, we can do at pre-authorize, and then we want to pass in the as role, and then we want to specify what role can access this. So let's assume we say role underscore to user, and how it's getting this role again is from the filters, right? We added that role here and we put it in the principal, like the authentication principal, right? So we already have it here. There you go, the authorities. So that's where it's getting the role from. All right, from our previous code, if you see the token we're using, right, let's just copy this and go back to the JWT. Okay, we still have it here. So it's seeing the role as a user role, right? So if we try this, hopefully our token has not expired. Let's just try this. We should still be able to hit this if our token has not expired, right? Okay, it's still coming up. Let's see. All right. So we are still able to hit this. Now let's assume that we change this, right? We change this that such that only admins can actually access this, right? So let's just do that. And of course, there are ways you can actually do this such that you can add multiple rows, right? You could use the as any role or any of those annotations, right? So now I should not be able to access this because my role specifically is a user role and not an admin role. All right. So let's just test that. Okay. We're good. and then I should get forbidden. All right, I hope that is clear. All right, in the next class, what we want to do is we'll then want to use the API gateway to call this particular service, to route to this particular service. And we want to do it seamlessly such that we are authorized to do this, like authorized to access this endpoint and all those resources. Awesome. Once again, I'm super thrilled to be your instructor on this journey towards building excellence. Please subscribe, leave a comment, click the notification button to stay updated with our new videos, and most importantly, please share with your friends. And I'll see you in the next video.